Hello dear student. Today we are going to discuss topic PLDs, that is programmable logic devices, which is a topic from third unit, which is in branch cyber security as well as in CS branch. So let us understand what is PLD. PLD stands for programmable logic devices. Fixed logic devices such as a logic gate or a multiplexer or a flip-flop performs a given logic function that is known at the time of device manufacture. A programmable logic device can be configured by the user to perform a large variety of logic functions. PLDs are the integrated circuits. They contain an array of AND gates and array of OR gates. A programmable logic device is an individual programmable electronic chip which can be used as an element to build digital circuits that can be reconfigured. Programmable logic devices have programmable elements that can be modified and programmed using a special program after the product has been manufactured. So here we can see the difference between fixed logic device and the programmable logic devices. So programmable logic devices can be used, reprogrammed and reconfigured. Programmable logic devices contain multiple logic elements such as flip-flops as well as AND and OR gates, which can be reconfigured by the user. The internal logic and connections may be modified by the user during the programming process, which is done using a dedicated software application. Programmable logic devices sometimes consist of a number of fuses which are intact in the original unprogrammed PLD. When we are programming the logic device and confirming the interconnections, you essentially blow out the fuses to make the connections permanent in a particular configuration as per your design. The process of entering the information into these devices is known as programming. Basically, users can program these devices or ICs electrically in order to implement the Boolean functions based on the requirement. So there are three types of PLDs, that is PROM, PAL and PLA. Programmable read-only memory. PROM stands for programmable read-only memory. Read-only memory is a memory device which stores the binary information permanently. The user has the flexibility to program the binary information electrically once by using PROM programmer. PROM is a programmable logic device that has fixed AND array and programmable OR array. The block diagram of PROM is shown in the figure. It consists of N input lines and M output lines. The N input line is used to take the input address from where we want to access the content of the ROM. Since each of the N input lines can be either 0 or 1, so there are 2 to the power N total addresses which can be referred to by these input lines, and each of these addresses contain N-bit information, which is given out as the output of the ROM. ROM is specified as 2 to the power N into M ROM. It consists of two basic components, that is decoder and OR gates. It is programmable logic device that has fixed AND array and programmable OR array. A decoder is a combinational circuit which is used to decode any encoded form such as binary or BCD to a more known form such as decimal form. The input of AND gates are fixed and not of programmable type. So we have to generate 2 to the power N fixed product terms by using 2 to the power N gates having N input each. These product terms can be implemented by using N into 2 to the power N decoder. So this decoder generates N minterms. The inputs of OR gates are programmable. That means we can program any number of required product terms since all the outputs of AND gates are applied as input to each OR gate. Therefore, the output of the PROM will be in form of sum of minterms. The initial programmable logic device was ROM, but it was not successful due to hardware wastage issues as well as exponential growth enhancement in the every hardware application. To overcome this issue, PAL and PLA were used. These two are programmable and efficiently uses the hardware. The diagram of PROM is shown in the figure, where we can see that it consists of fixed AND array and programmable OR array. Here, here, here we can see one of the example of PROM in which the two functions A and B are implemented with the help of PROM. So, as we have the two output functions, so we select the two OR gates, and number of input variables in these two functions are there are 8 different combinations, so 3 inputs are there. So we have selected the 3 input x, y and z, and with the help of the decoder these 3 inputs can be converted into 2 to the power 3, that is 8 output. So these 8 output, which are the output from the AND gate, are the minterm. So from the diagram it can be seen that in function A it is a function of 5, 6 and 7 term. So we can program the 5, 6 and 7 for the function A, and similarly we can see the B function where the B is equal to sigma m of 3, 5, 6, 7 term. So here we have programmed 3, 5, 6 and 7 for the B output. So in this way we can implement any function with the help of PROM. Now the next PLD device is PAL, that is programmable array logic. It is a programmable logic device that has programmable AND array and fixed OR array. The advantage of PAL is that we can generate only the required product terms of Boolean function instead of generating all the minterms by using programmable AND gates. The block diagram of PAL is shown in the figure. Now here we can implement the Boolean function with the help of PAL. Here again we have the two function A and B. A is equal to xy plus xz bar and B equal to xy bar plus yz bar. So these two function can be implemented with the help of PAL. In PAL we have the programmable AND gates and fixed OR gates. So for this problem we have 2 fixed OR gates and 4 AND gates. So this is shown in the figure that we have 3 inputs x, y and z, 4 AND terms and 2 OR terms for output A and B. So programming is done at the AND array plane, and there is a fixed plane at the OR array. Next PLD is the programmable logic array. Programmable logic array is a programmable logic device that is both programmable AND array and programmable OR array. Hence it is the most flexible PLD. At both the plane, OR plane and AND plane are programmable. The block diagram of PLA is shown in the figure. Here the input of the AND gates are programmable. That means each AND gate has both normal and complementary inputs of the variable. So based on the requirement we can program any of those inputs. So we can generate only the required product terms by using these AND gates. Here the inputs of the OR gates are also programmable. So we can program any number of required product. Here the input of OR gates are also programmable. So we can program any number of required product terms since all the outputs of AND gates are applied as inputs to each OR gate. Therefore the output of PL will be in the form of sum of product forms. PL is expensive and difficult to compare with PL. In this kind of method, every connection can be done using a fuse on each interconnection point. Wherever the unnecessary connection can be detached by the fuse below. Here again we implemented the function with the help of PLA. Here we have two output function A and B, equal to xy plus xz dash, b equal to xy dash plus yz plus xz dash. From the figure it is clearly shown that both the plane AND plane and OR plane is programmable. In the programmable table, it lists the product terms numerically, specifies the required paths between inputs and AND gates, specifies the path between AND and OR gate. For each output variable, we may have true or C complement for programming the XOR gate. Simplification of PLA. Careful investigation must be undertaken in order to reduce the number of distinct product terms. PLA has a finite number of AND gates. Here we have one example in which we have implemented the two boolean function with the help of PLA. F1 equal to sigma 0124, F2 equal to sigma 0567. In PLA, first of all, we need to minimize the function with the help of K map. So we can see the function F1 and F2 in its minimized form. Next, we can implement the PLA programming table. So we first write down all the unique product terms AB, AC, ABC, A dash, B dash, and C dash. We name the product term 1, 2, 3, 4. We have the inputs ABC. So we program the input. So AB, in AB we have the product term A and B in its true form 1, 1. In AC product term we have the A and C in its true form. In the product term BC we have the B and C in its true form. So the coding is done accordingly. Similarly, in the output we have to write the F1 and F2. So for the F1 we have the AB, AC and BC term. So we have written here as 1, 1, 1, and in F2 function we have the product term AB, AC and A dash, B dash, C dash. So we have written the 1 in the AB and AB, AC and A dash, B dash, C dash terms. We have programmed in this way. We can program the programming table. Now this is a diagram of PLA. So here we have implemented the programming table with the help of diagram. We have chosen 4 AND gates and 2 OR gates. So here we have programmed with the help of PLA. So these are some of the examples which we can solve and implement. Now let us see the difference between PAL and PLA. PL stands for programmable logic array, while PAL stands for programmable array logic. It has PAL has programmable AND array and programmable OR. PLA has programmable AND array and programmable OR array. While PAL has programmable AND array and fixed OR array. PLA speed is lower than PAL, while PL speed is higher than PLA. The complexity of PLA is high, while PAL's complexity is less. The cost of PLA is also high, while the cost of PL is low. The PLA offers more programming flexibility than a PAL. Logic function can be easily implemented using PLA. PAL is less flexible. It is less used than PAL, while it is more used than PLA. So this is all about the programmable logic devices. Thank you.